Okay, and the last thing I want to talk about is galvanic isolators. This is it. So a galvanic isolator, we talked about the purpose of that is to stop stray DC current from when you're connected to shore power, right? Only when you're connected to shore power. It's really kind of the first step to having an isolation transformer. There is no downside to an isolation transformer. Everybody wants one, but can't afford the weight, the volume, the cost. Those are the only reasons. Other than every other boat would have one. But for people that can't afford, because an isolation transformer could weigh 200 pounds, 250 pounds. On Ian's boat, he had two of them. We removed them. He was the gentleman up front on his 65-footer. We removed them because they had failed. They're 250 pounds. Taking those things off a boat is a life event. Now, of course, on a 65-footer, it's easy. You know, it floats. There's a lot of buoyancy. But on my sailboat, 250 pounds in my little sailboat would list my boat. I mean, that's a lot of rail meat. So I can't have an isolation transformer on my boat. I want one, but where am I going to put it? I just can't. So if you can't have an isolation transformer, a nice replacement, an isolation transformer is like $2,000, $4,000, $5,000, $6,000, depending on the size. This device is about $400 Canadian. So this is a really good idea of actually putting a device that allows to block stray DC current. And it's actually, if you have a multimeter that has a diode testing mode, you can actually test this to see if it failed. Remember what I talked about yesterday? How these devices can fail opened? The new ones will fail short, but if you want to see if it's actually blocking stray DC current, you put it in diode testing mode and you can actually test this device to make sure that it's actually blocking, that it's not failed closed and it's still blocking stray DC current. And when we get called in on a corrosion call or corrosion survey, which we do a lot, we probably do about 100 corrosion surveys a year, which are pretty involved. One of the things that the technician checks is actually making sure that that device is still operating and blocking current, stray DC current.
Does your meter do this?
Yeah, it does. Yeah. And then the other thing too is that you want to make sure of where this is actually connected, right? So this device here has to be in line, right? It has to capture all the AC grounding on the AC grounding wire, that green wire. It has to basically should always be mounted really near that receptacle, and it should be, the wire comes out of the receptacle, goes inside, and then from here goes out. The biggest problem that we see with this unit, besides failing, because there was kind of like like a lightning strike or something like that in the marina, there's a power surge which could cause this to die, is that people install this behind the panel and they think that somehow it's an equalizer. It's like a battery pulse thing. You know, you just connect two wires to your grounding bus and somehow it's going to magically stop stray DC current. Now, of course, the manual does not say that, but again, the manual needs to be read to be installed, and it says that it needs to be a choke point. It has to be in line, right? It's like sort of like locking down your house. If you have one door, it's easy to make sure who comes in and out. This is a lockdown mode. Nothing bypasses the device. If you have two shore power receptacles, you have two galvanic isolators. You know, on a lot of power boats, they'll have a forward one and an aft one, just for convenience, depending if they're stern tied, or if for whatever reason, not stern tied, but if they're actually, the power is at the front of the dock or at the back of the dock. And so on those boats, we'll end up having two galvanic isolators mounted near the AC receptacle. Highly recommend having one if you don't have one on your boat. Was very emphatic about it yesterday. Love this device. Absolutely love this device.
Is there any way of checking whether you have stray DC current?
Absolutely. The question is there a way of checking if you have stray DC current or stray DC current on your boat?
Other than your sinks disappearing?
Yeah, there is. Well, that's a good way. Yeah. No, it's intense. It's intense. It's you need to use what's called a silver chloride cell. We do that. That's a big service. I've got a guy flying to Manitoba next week. We do that everywhere. We fly everywhere. For insurance companies bring us everywhere for that. It costs money. It takes time. Bigger the boat, the more time it takes. You actually are measuring via voltage, via an anode, a reference anode, every through hull on the boat, every underwater metal throughout the boat to see how the bonding system is intact. And then you're going through permutations and you're turning every AC breaker on the boat on at a time and measuring what happens between the reference bonding system on the boat and your silver anode, chloride anode. As you do that, you're looking to see if the level is actually changing, right? Because you've got a range of what it is for, let's say, a fiberglass boat or wooden boat or an aluminum boat. And you're actually measuring that range. And then you do a full-on report. And you say, okay, when the shore power breaker is off, here's what your protection level is. As soon as you turn the breaker on, your boat is now, most of the marinas, you're actually helping some other boat. That's why your zincs are dying first or sooner. It's not that your boat's not perfect. It's there's a boat beside you that isn't. And your zinc is helping him. So that's as soon as you connect to shore grid, you're perfect protection on your own. As soon as you connect to the grid, your protection level goes down. How do you solve that? Galvanic isolator. You don't have one? Well, then you're helping every other boat in the marina that is unprotected. What happens when you turn on the hot water tank? What happens when you turn on the battery charger? What happens when you turn on the inverter? What happens? And you see what happens to your bonding system. And you want to make sure that that bonding system always stays within range. But if the delta is dramatic between what happens when you connect to shore power and not shore power, then you're like, well, your zincs are not going to last long because you're now such in a deficit because you're helping the marina. You're totally protected, but the marina is underprotected. And your boat is literally facilitating all these other boats that have little or no zincs. Hence why boat manufacturers like Sea Ray, for example, Marquis, all put isolation transformer stock on their boats. Like it's an expensive item, but they all put it on the boats. Like it's not a question. Same thing, Fleming's, all these manufacturers all put isolation transformers as a way to isolate the boats. Because when you have an underwater damage, I don't know if you hang out at a clubhouse or in a marina long enough and you have friends, you want to hear a horror story, is hear what happens to stray current corrosion on a boat. And I'm not talking about big boats. I'm talking just even a 30-foot pursuit with 2 engines in the water or the legs of a $40, $50, $60, $70, $80,000 of damage. Summer's gone, right? I mean, this doesn't get solved in an hour, right? The legs are completely gone. Like there's almost nothing. Like sometimes they're actually worried that the boat's going to sink. Like they're like, I don't know if we can tow this. Like you forget your own propulsion. It's like, I don't know if it's going to stay intact. Like you should have another boat beside you as your boat is being towed to the dock. It's real. So galvanic corrosion is real, and it's not about you not having a good boat. It's about another boat around you that doesn't know they're not a good boat, and they're sucking you dry. And so we do that through corrosion surveys, but it's time consuming. It is time consuming. Yeah, go ahead. I'll come to you. Yeah.
I have a battery question. What happens when people dry store their boats for 6 months here on land? What kind of things should you do to preserve the batteries?
Well, you should take the batteries out. Should take the batteries out. If they're flooded, they don't allow battery chargers on those. It makes sense for fires, right? The whole thing would catch on fire. I would, if I had a boat in dry storage, I would take my batteries out. If I had AGM, maybe I wouldn't, but I probably would. I'm just that person. 6 months without a charger, I'd rather have a charger.
Do you store them inside?
Oh yeah, absolutely. You charge them inside and then you put a trickle charge. Absolutely. Question?
Yeah, with the galvanic isolator, you said there's a way of testing it?
Yeah, with diode tester, like a multimeter.
Okay.
Yeah. There's a little diode section. Yeah, question?
Can that be the cause of the reverse polarity in an AC system if you're the galvanic isolator not operating right?
If you're galvanic isolator, okay, what is reverse polarity? Let's go to the top. I didn't think about it. Let's walk through it. This is how my mind works. Okay, reverse polarity. What is reverse polarity? First thing, reverse polarity is that your hot and your neutral are swapped, inverted, reversed. Okay, what does a reverse polarity do? The light shows a differential is actually literally wired between the neutral and the ground, AC ground. If the neutral is at 0, which it should, right, because it's grounded at the source of power, right, whatever it is, there should be no differential between the ground and the light, right, and the AC. So the light is not going to light up. 0 is 0, light bulb between two things that are at 0, no differential, no light bulb. If your ground is disconnected, it's floating, because your galvanic isolator is a non-fail-safe model. The fail-safe, when it fails back together as one wire. But if this device fails open, your ground is now floating. Floating to what? You don't know. It's floating. Your neutral is not floating, and so you could see a flicker on that light. So the answer to your question is yes, it is possible that a failed galvanic isolator that is non-fail safe makes the reverse polarity light flicker, not brightly, but a little bit when you actually don't have reverse polarity.
Because I have that, it flickers, and then it'll cut off, it'll stop the charger, it'll just cut out, the whole system cuts out.
Do you have an isolation transformer on your boat?
No.
Yeah, that one I need to think a lot bit longer on. Don't know. Yeah, I don't know. I like those kind of problems though. Yeah, I do. All right, other questions? Yeah, go ahead.
If you have an isolation
Oh, just 1 second. Yeah?
if you have an isolation transformer, are you completely immune to the effects
Oh.
of other boats?
Yeah, you're in heaven. You're in heaven. It's paradise.
So it doesn't matter how those
It doesn't matter. You don't care.
Yeah.
Oh, you don't care. It's completely done. Yeah, you're done. You're literally in your little heaven. You're completely like if you're in the middle of the ocean. And by the way, any boat that, if you have reverse polarity that comes to your boat, doesn't care. It's going to fix the polarity. Yeah, isolation transformers are a dream, other than weight, volume, and cost. No doubt, nobody's ever said, oh yeah, but it's not a good device. Of course on the internet, but you're talking to pros, nobody's going to say that. It's universally acclaimed, other than price, weight, and money, and volume.
So what is a 30 amp isolation transformer?
$2,000 Canadian, yeah. But it's the weight. You know, on a boat, you know, this size thing is, where do you put it? And where do you have a shelf that can hold 200-pound weight, 100-pound weight? Yeah, well, engine room, but an engine room has a lot of stuff. Or, you know, it's funny, you know, it's not that easy. It isn't. If you have space for it and you can afford it, get one.
Question about lithium-ion batteries. Do they need the bulk absorption flow thing, or because they just suck so much power?
It's mostly just bulk, and there's a very short, depending on the battery manufacturer, it's pretty much, we'll simplify, it's pretty much bulk and float for all intents and purposes. Some people will say there's a small absorption, but it's pretty much full throttle, 100 miles an hour, and then stop, almost.
Does the smart alternator help?
Yeah. Oh, yeah, absolutely. The external regulator will actually do that. Yeah. You had a question.
Just to comment on reverse polarity, sometimes the connection on the dock, if you don't twist it in enough and it's a little bit loose, you can get that reverse polarity coming on and off.
Yeah, and that is because you don't have a good connection, and the neutral and the ground, if they're not the same potential, that light is going to light up. It's not a light that only works at 120 volts. It works at 4 volts, 5 volts, 6 volts. You see a little bit of a flicker. Yeah. Reverse polarity, by the way, is one step from insane, crazy, catastrophic, end of world situation. One step away. Second step, and believe it or not, a lot of boats have this because a lot of boats are inclined to pay people by beer, is to bring a household electrician to your boat. And that household electrician, in all its knowledge, who's paid and is trying to do you a favor, thinks that land and water are the same. And decides that stupid that your AC neutral on your boat is not grounded to your AC ground. And he's like, in a house it is, so I can't imagine why you wouldn't do it on a boat. And he puts a little jumper between the AC neutral and the ground on your boat. And he's really proud of himself. Probably asks for maybe another 6-pack. Hey, I saved you one. You owe me one. What he doesn't realize is on your boat, your AC ground is also tied to your DC ground. And your DC ground is tied to your battery negative. Your battery negative also is tied to your engine. Your engine is also common to your bonding ground. Your through hulls are grounded. Your engine is grounded. Your rigging is probably grounded, potentially, if you have a lightning ground. And by putting the neutral to the ground on the boat, when you have reverse polarity, now that the hot is on the neutral, Guess what happens to all your grounds on your boat? They're all hot. Your engine block is 120. Your rigging is 120. Your through hulls are 120. Everything is 120. And literally, I'm getting chills, but that's exactly how people die. That's how you get 120 in the water. 2 steps. Reverse polarity, and this person that thinks that everything on land should be on water. 2 simple little errors, 2 little things. And by the way, the people and the children swimming in the water, and especially if it's fresh water, and generally it's around marinas where there's a freshwater intake because it's a bay. Fresh water is not conductive, or barely. Children will be swimming because they're having fun, and they're going to drown. And no one will ever know that they drowned because of electrocution, because there's not going to be any burn marks. They'll just simply be, oh, little Timmy, I don't know. And then generally sometimes a mother or a female goes, and for whatever reason, because of their height, I can't remember, this is not my field, they'll drown too. And the men, because they're taller, they can get away because of the wavelength, don't understand it. But they might be, so generally it's a couple people that drown on the way in to save the person that's drowning for the first part. Yeah. So it's pretty serious, it's not a joke. And I cannot tell you how many boats I've seen where there's an AC neutral to ground tie on the boat. Cannot tell you how many have that. It's just a simple little wire where someone thinks that the land is the water. It's suicide. It's like literally Russian roulette, putting a loaded gun on the table and just, there's enough chambers. I mean, eventually you'll get to marina with there's a reverse polarity. There's a lot of, but you're just waiting. And imagine you're a boat, everything on your boat, the engine. Now you could touch your engine, your sink at the same time. No problem. It's like a wire, a bird on a wire. You're good, right? I mean, you're just simply, the boat's just 120. You're just part of it. Like you can be on a wire, you can do whatever you want. The problem is that people in the water are a path to ground now. And your through hulls are pumping out 120. Or your propeller, right? Or your shaft, or your rudder. Or someone comes to the boat and, touches something. Now that's 120, because now maybe the backstay or the shrouds are 120, because you have a lightning. Yeah, absolutely. It's super easy. Oh, this device would tell you instantly. It takes like 5 seconds. You literally measure, you disconnect your boat from shore power, make sure your inverter's not on, because they'll ground AC ground to neutral. Inverter's off. Shore power is disconnected. And I don't mean just the breaker, I mean literally. And you take your multimeter and you connect it between your grounding bus, AC grounding bus, and your AC neutral. If you have no source of power on your boat right now, your AC neutral and your AC grounding bus should be open. There should be no path return. You got to make sure you check for that, and it should be open. And the other thing you should check, and a lot of people don't have this problem, and they also get corrosion, you should also make sure that your AC grounding and your DC ground are the same. That should be short circuit. A lot, like I'm talking like 30% of you don't have that. Yeah, a lot. So that means that you have no ground on your boat. So you're back to circa like 1898. Like before there was a 3-wire system. Yeah. Yeah. And that's actually really common too. Question?
Just repeat the last part. You said your AC ground and your DC ground should be the same?
Should be the same. They should be continuing between the same. All grounds are common. That's why the word common ground is used. Yeah, AC ground and DC ground have to be connected. You look at Nigel Calder, he does these really nice diagrams and he shows all the different bonding grounds, right? You got an SSB ground, an RF ground, a DC negative ground, an AC ground, a bonding ground, a lightning ground. All grounds are common, right?
Come back to the Honda generator.
They actually don't have a return path at all. They're not bonding at all the neutral to the ground on the generator. It's just 2 wires coming out. Even though it's 3 wires going in.
We have about 5 minutes left.
Oh yeah? Okay, yeah, all right, 5 minutes.
The museum's closing.
Yeah, all right. So I'll do that question a little bit later. Any other questions on what we talked about before everyone goes home and maybe has a chill tonight? All good? I want to thank everyone for being here. and spending your valuable time, especially considering how beautiful it was outside today. That says a lot. All right. Thank you, everyone. Thank you.